Yo, what's up? It is Tuesday, March 31st of 2020, and today we are talking about the remainder and factor theorems. All right, so let's get started. So the remainder theorem, this neat little theorem that says that if we use synthetic substitution, we can find what p of x is whenever it's evaluated at some number. So what we could do is plug this x equals 5 into p of x into our function. This will work for any function. This is just a particular one. We could plug this in. We already know that we could do this. And we could solve to find what p of 5 is. -4 times 5 plus 7. So p of 5 is 25 minus 20 plus 7, and p of 5 is 5 plus 7, which is 12. So p of 5 equals 12. So we can solve it that way. But what would happen if this was a big number? Say it was 3x to the 4th, and then we went further down. It would just make for a lot more work to have to plug all of this in and evaluate all of these different exponential values. So there's a remainder theorem that we're learning about today that allows us to use synthetic substitution. We've done synthetic division. Synthetic substitution to get this same answer where p of 5 equals 12. So I'm setting this up here. It is the exact same thing. You'll notice that this should be like 1x squared. Here's my 1. -4, 7, 7. And we're evaluating at x equals 5. So I'm going to put a little 5 down there. You might remember in the past, whenever we do division, this might be x minus 5 equals 0 or something. The reason that we flip these is because we want to show when x equals to that number. That's why we flip it. So we have to move this 5 over to make it a positive 5. So whenever this was x minus or plus a number, we did the opposite down here because we wanted to show when x was equal to that. Well, this is giving us when x is equal to that, so we don't have to flip it. We're just leaving it as 5. So we're going to use the same techniques as synthetic division, but with synthetic substitution. So what we do with this one, we drop it low, and then we're going to have 1 down here. 1 times 5 is going to be 5. -4 plus 5 is 1. And 5 times 1, we already said was 5. 7 plus 5 is 12. So the remainder theorem is saying that whatever the remainder is, pretty tricky, whatever the remainder is what this function would be whenever it's evaluated at x equals such number, which in this case is 5. So we see that we have 12 here, and we also have 12 there. So it works. It's the same thing. Let's try another one. Find f of -3 if f of x equals, oh my gosh, look at this one. It's a lot more intense. We could plug it in. We can plug it in to check. If you want to plug it in to check and make sure that we're right, you go for it. But I'm going to do this using synthetic substitution and see if it's a little quicker. So -3. I just want to write my coefficients. So -2. Oh, -2. Now notice that there isn't anything in the spot for x to the 3rd right here. There's no x to the 3rd. We go from 4 to 2. If there's no x to the 3rd, we should write a 0. And then x to the 2nd, we have a 3 as a coefficient. X to the 1st, we have a -15, and then 9. Okay, and then we want to use our synthetic division skills and synthetic substitution and figure this out. So let's see what our remainder comes out to be. So we're going to bring this -2 down, drop it low. -3 and -2 being multiplied together will give me 6. Add those together, that's still 6. 6 and -3 is going to be -18. -18 plus 3 is -15. Negative 15 times negative 3 should be 45, which is going to give me 30 when I combine those. And 30 times negative 3 is negative 90. And if I combine those, this should be negative 81. So our remainder is negative 81, which also means by the remainder theorem that f of negative 3 is equal to negative 81. If you want, you can plug this number into each one of these and make sure that it works. If you do that, make sure that you put the negative 3 in parentheses into your calculator when you raise it to a fourth, or else it will mess it up. It needs to be in parentheses to the fourth. Okay? But f of negative 3 is negative 81. So that is using the remainder theorem. There's another theorem called the factor theorem. So we want to do a similar thing, but what we're telling is if this binomial is a factor of this polynomial. So a factor meaning like 2 and 3 are factors of 6, saying that can you multiply x plus 6 by something to get this polynomial? If it is one if it is a factor if the remainder is 0. So whenever we do this, if the remainder is 0, then we can tell that it's a factor. Okay, so let's look at this. We need to write x to the third is going to be 1. X to the second is going to be negative 1. X is just going to be negative 30 and 72. Okay, and this is x plus 6. Remember earlier I said that if it's x equals that number, then we're going to put that number in our little box. This is x plus that number, so to find what x is, we should move it to the other side. So x equals negative 6 if we subtract 6 from both sides. Okay, so that means that in our little box over here, we're going to have negative 6. Now we're going to use synthetic again and show that these are factors. Let's see if it is a factor. What are we going to do with this one? You're right, we're going to drop it low. So negative 6 times 1 is going to give us negative 6. Negative 6 plus negative 1 is negative 7. These multiplied together, negative 6 and negative 7, are going to give us positive 42, right? Negative 6, negative 7 is positive 42. Add those two, negative 30 and 42, should give us 12. 12 and negative 6. If we multiply those, that should give us negative 72. 72 minus 72 is 0. So since this is equal to 0, whenever our remainder is equal to 0, x plus 6 is a factor of x cubed minus x squared minus 30x plus 72. Okay, so now we can see what these what that breaks down into by rewriting this. So we can say that x plus 6 is a factor, and now x squared comes from right here. X squared, we want to go one less than whatever this degree is. So this degree is 3, so this degree should be 2. So 1x squared minus 7x plus 12. Okay? So here is what this breaks down into. X plus 6 times x squared minus 7x plus 12. And we could break that down into x. I know that if we wanted to find what multiplies to give me 12 and adds to give me negative 7, I could find that -3 and -4, if they're multiplied together, they equal 12, and -3 plus -4 is -7. So I can write x minus 3 and x minus 4. Oops. Minus 4, right? We have -3, -4 will give me 12, -3 plus -4 is -7. Okay, so if I wanted to completely factor this, I could also factor using this synthetic division. Okay, so here is my final factored form, and we can say that x plus 6 is indeed a factor of that polynomial. The last thing I want you to do is, in your exit ticket, tell me, is x plus 8 a factor of 2x cubed plus 15x squared minus 11x minus 24? Okay, so I'm going to get you started, but then you need to finish this. So x plus 8, I can rewrite it as what? -8 in my box, yep. And then I'm going to bring this 2 down from my 2x cubed. I'm going to bring this 15 down, -11 down. We're just looking at the coefficients. And -24 down. Okay? For the synthetic division, we're going to bring this positive 2 down, and then we're going to start multiplying. -8 times 2, write it there. Add these two together, bring it down, multiply, add them, bring it down, multiply, add them, bring it down. That will tell if it's a factor. I want to know if it's a factor, and I want it factored to its simplest form. So once you have it factored, if it's 0, then if the remainder is 0 here, then you know that it's a factor. Then I want you to break it down. So whatever this comes out to be, you'll have 2, a number there, a number there. This part will be part of your new factor. If you forget, look up at our past example. Okay? Everything is the exact same. Numbers are different. Steps are the same. All right? Good luck. Stay inside. Stay safe. Hope to see you soon. Maybe on Google Meet or something. Google Hangout sometime soon. Adios, muchachos. Bye.